AI agents book my meetings, write my emails, and analyze my data while I'm asleep. This is not science fiction. This is happening right now. But here's what most people don't understand. ChatGPT is not an AI agent, and that confusion is costing you serious productivity. In the next 10 minutes, I am going to show you exactly what AI agents are, the 3 components that make them work, and how you can build your first AI agent even if you've never written a line of code. Now, if you are new here, I am Priyanka Vergadia, a cloud and AI expert with 15 plus years of experience in big tech companies. And in this channel, I talk about careers and tools in tech. Now, today we are diving deep into AI agents, what they are, how they're fundamentally different from language models, and the exact tools that you need to build an AI agent. Now, what exactly is an AI agent? Now, here's a simple definition. An AI agent is a system that uses a language model to achieve a user-defined goal. But here's the critical difference that most people miss. Now, AI agents don't just respond. They reason, they plan, and execute actions in real world. Now, think about booking a flight. If you ask ChatGPT to book your flight, it'll give you instructions on how to book the flight, maybe a list of websites to check. But if you ask an AI agent to book your flight, find me a business class seat to Tokyo next month under $3,000, the agent will actually search for flights, compare options, ask for your preference, and actually complete the reservation for you. All of this happens autonomously within one conversation. That's the power of AI agent. Now, every AI agent has 4 core components that you need to understand. The first one is the language model. Language model is the brain. It's the reasoning and decision-making engine that powers everything. Now, the second one is the tools. These are the hands and the senses. They allow the agent to interact with external systems like the APIs, the databases, and the services. Third is the orchestration layer. Now, this is the central nervous system. It governs how the agent processes information, plans its actions, and executes them to achieve the goal. Now, this orchestration layer is what makes the system truly agentic, which means able to work autonomously towards a goal without human constantly intervening. Now, let's break down each component, starting with the language model, the brain of your agent. Now, here's a critical point that trips up a lot of people. The language model itself is not the agent. ChatGPT, Claude, Gemini, these are just wrappers around language models. They are powerful text processors, but they themselves are in a box. They can't access real-time information, browse websites, or query databases because they have no access to that. They only become agents when you connect them to the tools and wrap them in the orchestration layer. Now, when building an agent, you have several options for which brain to use, and the brain is the language model. LLMs like GPT-4o, Gemini 2.5, Flash, DeepSeek, these are your general purpose workhorses. Your LLMs, excellent for tasks of medium complexity. Think of a project management assistant that needs to understand nuanced requests and coordinate multiple tools. Next, you have small language models or SLMs like Gemma or DeepSeek R1 Distill. These are efficient and cost-effective, perfect for simpler, high-volume tasks. For example, an agent that just categorizes incoming support tickets or routes customer inquiries. And finally, your reasoning models like OpenAI's O3, DeepSeek R1, or Claude Opus, these are the heavy hitters. These models generate long chain of thoughts before answering. They literally think through a complex problem. You would use these for agents tackling tough coding challenges, advanced mathematics, or complex scientific problems. The model you choose depends on your specific use case, your budget, and the complexity of the task that your agent needs to handle. Next, let's get into the superpower of AI agents, the tools. But before we do that, if you're serious about truly understanding and building with AI agents, let me share an amazing resource with you, DataCamp's AI Agent Fundamentals Track. I've used DataCamp for years to level up my own skills, and what I love about this is how practical their courses are. This track is perfect for beginners, no prerequisites, and it guides you step by step, starting from generative AI for business to see how these technologies actually get applied in real world. Next, it's the introduction to AI agents, which breaks down the core concepts into real world use cases with zero coding. And when you're ready to get hands-on, building scalable agentic systems teaches you the frameworks like MCP and A2A, so you can build agentic systems that work in production, not just in theory. Plus, you get an AI agent's cheat sheet for quick reference, and when you're finished, you will earn a statement of accomplishment to boost your resume on LinkedIn. Now, I genuinely recommend DataCamp. I literally learned Python through DataCamp years ago. Check out the link in the description and start for free today. Now, the tools. This is where AI agents get their superpowers. Tools bridge the gap between what the language model knows internally and what it can actually do in the external world. There are three main types of tools your agent needs, and understanding these is crucial for builders. First is the extensions. Think of these as APIs, the wrappers that connect your agent to external services. Weather services, flight booking systems, Google Maps, payment processors. Any external API can become an extension. Now here's how they work. You provide the agent with a description of an API endpoint along with the examples. The agent learns which endpoint to invoke and what parameters are required. At runtime, the agent autonomously decides when and how to call these APIs based on the user's goals. Now here's an example. You give your agent access to Get API User's ID endpoint. When someone asks, what's the email of this user, the agent knows exactly which API to call. Now, second tool is functions. These are the custom chunks of code that you write and control. This is the most powerful and secure option because the code runs in your application, not inside the agent. The agent decides which function to call and fill in the arguments, but you maintain complete control over the execution, the security, and the post-processing. Now here's an example for this. If you have a proprietary calculate risk score function in your backend, you can expose it to the agent as a tool. The agent doesn't need to know your complex business logic. It just knows when to use it. Now, third tool is data stores. Think of this as your agent's knowledge vault and memory system. You connect your agent to databases, vector stores, spreadsheets, PDFs, internal wikis, any existing data sources that your organization has. This enables retrieval augmented generation, or RAG. The agent can exactly pull back the information that it needs to stay accurate and current. Now here's an example, a customer service agent which accesses your orders in the database. When someone asks, where's my order? The agent retrieves the exact real-time shipping information from your database. Together, these three tool types transform a passive language model into an active AI agent that can interact with your entire technology stack. Now, here's what separates good AI agents from great ones. Memory. Memory is what allows an AI agent to learn from past interactions, maintain context across conversations, and get smarter over time. Now think about it. Without memory, every conversation with your agent starts from zero. It's like talking to someone with amnesia, right? You have to re-explain everything every single time. But with memory, your agent remembers previous conversations, user preferences, past decisions, and historical context. There are different types of memory that AI agents can use. There's short-term memory, which keeps track of the current conversation and tasks at hand. There's long-term memory that stores information across multiple sessions, like your preferences, past projects, frequently asked questions, and successful strategies. And working memory is what the agent actively uses during reasoning and decision making, pulling relevant information from long-term storages when needed. Now here's an example. If you tell your scheduling agent once that you never take meetings before 10 a.m., it remembers that preference forever. 3 months later, it will still avoid booking early morning meetings. Memory is what transforms a simple tool into an intelligent assistant that actually understands you and your needs. So, you've got a brain and you've got tools. But how do they work together intelligently? That's the job of the orchestration layer. This is the critical process that governs your agent's decision-making logic. It manages the agent's memory, maintains state, and controls how it plans and executes action. Now, this is often implemented using cognitive reasoning frameworks. You've probably heard of some of these: chain of thought, or COT. This prompts the model to think step by step, breaking complex problems into a linear sequence of simpler thoughts. Tree of thoughts, or TOT. This is a more advanced technique. It allows the model to explore multiple reasoning paths simultaneously and then choose the most promising one. And then there's REACT, which stands for reason and act. This is the classic agent loop, and it's incredibly powerful. The agent reasons about what it needs to do, chooses an action like calling a tool, observes a result from that tool, and then reasons again based on the new information. This loop continues until the goal is achieved. Now, you can structure your agents into two main architectural patterns: single agent systems, which is simple and effective, one language model in a loop with a set of tools executing the entire workflow. Now, multi-agent systems are like teams of specialists. The workflow is distributed across multiple coordinated agents, each with their own expertise and the tools. Multi-agent systems can follow a manager pattern, where there's a central manager agent that delegates tasks to specialized worker agents. Now here's an example. A manager agent planning a marketing campaign might delegate copywriting to a copywriting agent and data analysis to a data analysis agent. Or they can follow a decentralized pattern where agents hand off tasks to each other as peers without a central manager. The pattern you choose depends on your workflow complexity and how specialized your tasks need to be. As AI agents become more common, we need standardized ways for them to communicate. That's where agentic protocols come in. There are two major protocols you need to know about right now. The first one is the Model Context Protocol, MCP, from Anthropic. This is an open standard for how applications provide context to language models and connect them to external tools and services. Now think of MCP as standardizing the plugs for the tools. Instead of custom integration code for every single service, you use MCP to create universal connections. Now here's an example. An AI agent in Slack could use MCP to pull the latest project updates directly from Asana and display them in your channel. No custom integrations required.